parameters, right? And parameters as well of their notations and then after their units. And now I want to tell about the SI. Okay, SI units and of the constants which will be used for both electric as well as of magnetic field. So first one, I gotta go with the SI. Okay, so this SI is maybe a fundamental unit, and then it's mainly for what are the parameters and used for this action of electric as well as magnetic field. The first one, I got the heading, that means for the quantity. Something I want to share about the more electrons, that means for the packing of electrons, we said about the form of a quantity, okay? And now for this quantity, and what's going to be the unit. And afterwards, I want to say about the abbreviation, okay? Abbreviation of what the things. Now I go with a small tabular structure. This tabular structure and a quantity in the form of a length. The first one, I go with the length. So length, as usually everyone knows, length is a form of a meter. Is it right? So what I do, I just write the form of a meter, M-E-T-E-R. Usually we know the abbreviation of meter. That means M is the small form of a meter. Is it right? And so M I do. Okay. And after length, I go with the mass. Mass means what? So weight is different from the mass. Is it right? Because weight means that's a simple weight you tell about any substance, and mass means it's about the gravitational force. And when I go with a simple weight, I may say, for example, it's a 10 kilogram. And when I just give a pressure for the 10 kilogram, it for the weight, the varies with respect to gravity. Okay. So this pen, if I say it may be the form of a small grams, and when I give some pressure or when I just compress or anything, at the time, if I just try to raise the pen, and it may give some more kilogram based on external force. Okay. So that's why, and the term is called what? A mass. Because whenever we go with any such objects of this earth, everything is under the gravitational forces, right? So we have to measure the weight with respect to gravity, means that's called what? Mass. And that mass is going to be usually in the form of a kilogram. So kilogram is a actual simple representation of any such objects of this world with respect to gravity. And the notation of this kilogram is about kg. And next one is about the very important one is the for time. At what time you receive electricity and what time the magnetic field applies. So the time is a main constraint of this world. So that's a very important parameter of this SI unit. You know the standard notation of the time in the form of, or the time will be measured in the form of seconds. So I do go with the second. And then you know about the second term. The unit of the second term is a what? Yes. Is it right? And now I go with this finally. It's a current. So there will be no such element represented for the magnet. Okay, the current is the final one. So with all these things, if it satisfies, and there comes a, because the current will be going in form of a meter at this particular level, what type of meter, either the voltage or current, and then how much objects, how much substance it's measuring the current, or how much substance is getting the current, and then what's the time at the time of current entering the object or leaving the object or entering the any such circuit. So that's why before I represent the current, I record there's three terms. That's very important term to represent the current. Okay, so you know current will be having the form of an ampere. So the ampere will be represented by the simple unit of A. Okay, very good. Is it right? So this is about the SI, and it comes under unit number 1 and the second topic. Is it right? I got the point. Is it right? Thank you. Thank you very much.